Good.
Good morning, everyone. How are you? Good morning. So we're going to talk to you about the Open Run RFI, yes, and we're going to announce the results. I know you want to know, but you'll have to wait. And by the way, we upgraded our presentation to the future of mobile access, which is much more inspirational, right? Now, let me explain you why, and why we think Open Run is the future. If you remember 10 years ago, 10 or 12 years ago, I know you don't remember, I know you're all too young, you were all in high school, but okay. So believe me, 10 or 12 years ago, Huawei got the first contract in Europe, at least the first big contract in Europe. That was relevant because that actually marked the start of a new cycle in the industry. Of course, that meant a lot more competition for the established players at that time, and that, of course, drove price down. But that's probably besides the point. Most importantly, it drove innovation. And it accelerated innovation, and that proved to be a much more sustainable way of reducing the total cost of ownership. It had a long-term effect. It probably lasted, the effect lasted for 5 years, maybe 6 years, before the industry found a new equilibrium point. Now all good things come to an end, and then when we all went back to business as usual, so innovation slowed down a bit, and the pace at which we remove cost out of the equation also slowed down. Okay, it's not a drama. I mean, we're still a functioning industry. We are about to give birth to 5G, actually, and good things are going to happen. But the question is, can we make it better? And we believe the answer is yes. We've spent the last 4 years, maybe 5 years, thinking and considering our options as to how we can ignite another such cycle in the industry. We considered maybe bringing new vendors. But if it's just about increasing competition, that doesn't last very long. Eventually, we decided that the way forward is Open Run. Why? Well, if you look at the architecture today, how a base station is put together, you'll find software, very well-done software, that runs on proprietary hardware, full of accelerators, for all the right reasons, but it's proprietary. And that connects through a closed interface with proprietary radios. That's why there is only a handful of players in the industry doing this. Now, that's a captive market, right? It's not surprising that innovation has slowed down. Now, what if you could run the radio in a software that runs on general purpose processing capacity? And what if you connect that with any radio to just put together a base station? Well, then you would not be tapping on a handful of suppliers. You'd be tapping on maybe 20, 30, 50 different companies of various sizes that are eager to bring their best product. They're hungrier for business. They want to innovate. And by the way, there is also space for the incumbent players. No one excludes them. We think that by doing that, straight away, there is about a 30% saving that's possible on the total cost of ownership, even without factoring the innovation and what we can bring in the next coming years. However, if it's done the way it's done, is for all the good reasons. So it's not a mean thing that someone decided to just keep it closed and captive. It's a good architecture, the one we have today, and it's brought us where we are. So what's the trick then? Well, currently the trick is, if you want uncompromised Open Run, so you don't want to compromise performance or capacity, you probably need to back off a couple of releases, 3 EPP, and go back to 2 releases behind. So today, if you want to do release 15 in such an open, general purpose processing, open interfaces, you will probably compromise on performance or capacity. But if release 13 is enough, then you can probably do it. That's a gap that there is today. We are working on closing that. Now, would that work? even if you move back to release 13. Well, about a year ago, we had 2 pilots in India taking commercial traffic. We did them with 2 different companies that had products on their portfolio that were the most similar thing to our vision. Those were Parallel Wireless and Altistar. We set up some clusters, small clusters in India, and we delivered 2G, 3G, and 4G in different setups. After some optimization and after some work, we were very satisfied. It actually works. OK, it may not be current release of 3GPP, but it does a really good job. And it has the potential to deliver the savings. And if we do it well, it also has the potential to tap onto a bigger ecosystem. So we were very excited. What did we do then? Well, we took our project and our efforts to TIP. We joined efforts with Telefónica and the other operators. We wrote a specification of what we want Open RAN to be, and we released an RFI, which is what we're going to announce today. Our future plans include more pilots. So imminently, we're going to start another pilot in Turkey with Parallel Wireless on their new product, developed 1 year later, more capable, and including new technologies. And right after that, beginning of 2019, we're going to do another 2 pilots in Africa with 2 companies that we're going to announce in a few minutes. Now, we're no longer proving the technology. We did that already, and we know it can work. These pilots are more aimed at trialing the operational model, the commercial model, the rollout capabilities. And as such, they will be larger scale, not just a small cluster, but a larger scale trial. So we'll talk about the RFI and Open RAN in a minute. The other thing I wanted to talk about today is a slightly different concept that is called crowd-sell. You could see it in Chairman Axel's slide this morning as a slightly different project group. What is crowd-sell? It's like the extra small version of Open RAN. In essence, it is a small cell. Why do we need, and why is different? Why do we need crowd-sell? Well, most of the industry thinks, there is like an urban legend, that with 5G, us operators are going to be rolling out 100,000 small cells in the major cities in Europe. That's not going to happen. At least not the way we think today of a small cell. Why? Well, if you think of a small cell, well, first you need a landlord where to attach the small cell, and you need to pay the rent. You need to pay the rent to a landlord who thinks you really need him. That's not cheap. You, of course, need to bring fiber to the small cell or other kind of backhaul. And you need to pay the energy, and you need, of course, to provide the maintenance. If you add rental to power, maintenance, and backhaul, these all adds up to, it's not going to happen. When you multiply by 100,000 small cells in Europe, there's no way. Now, it's not that we don't need small cells. It's not that they're not good for capacity and coverage. They are. They're just too expensive. So we thought, what if we would backhaul a small cell using the mobile network? Yeah, that's a relay, right? And you may think, well, that will not add any capacity. Well, no. That's the beauty of the radio. It does. Right? Maybe a fraction of what a regular small cell would do, but for a fraction of the cost, which is much smaller. We are actually we called crowd-sell. We are rolling out several hundreds already in the closed version, right? So buying them from some of the well-established operators in a closed format. We are rolling them out in several countries already, and it works really well. Now we thought, what if we open them as well? What if we just turn them into some software that you run like into a small CPU? And then you connect to any radio to do the job. Well, that actually opens almost endless possibilities. You could do that on a Raspberry Pi. We've done it. You could do that. Actually, I could use your laptop. Your laptop may be my next base station. We've tried that. Not on your laptop, on mine. And it works. So we set up this this project group. We launched it in February. We also released an RFI. We're also going to announce results today. And out of interest, if you go to our booth, you'll see a working demo. So with that, what's next? In both Open Run as well as CrowdSell, what's next is, of course, the scalability to 5G. Remember what I said before? The trick to have Open Run deployed and taking commercial traffic today is to back off a couple of releases in 3GPP. Now, that is so because we haven't worked on narrowing that gap hard enough yet. But we are already seeing that there are many things that we could do to narrow that. If we just leave things as they are, in a couple of years, we would see a 5G base station following this model, following Open Run. If we accelerate, if we do, use some clever things, we can probably reduce that to maybe a year. We will see. But it's definitely the next big thing that we're going to do. So with that, I'm going to give the floor to David. And then later on, I'll be back to announce the results with him. Thank you.
Thank you. Thank you very much, Jago. It is a pleasure to be here with all the TIP community to share our progress on Open Run. And it's also a pleasure to be sharing this stage with Vodafone. As you know, Vodafone and Telefonica are competitors. We fight a lot for customers in many different countries. And we know that competition makes us stronger. We know that a lot of the decisions that we take internally are driven by what competitors are doing. And because we know that, we decided to work together to help our industry become better by means of competition. We want to increase the competition in our industry because we know that that brings innovation. And this industry needs innovation in order to grow. It's not only us, the operators, that will grow with innovation, it's the whole industry that will grow if we help everybody become more innovative. OK, so if you remember last year, we presented here our vision for Internet para Todos. Internet para Todos, Internet for All, is our project to connect the unconnected in Latin America. In Latin America, we have now about 100 million people that are not connected to the Internet. These are people that are left in the 20th century, not because they want, but because we're unable to connect them. These people live in remote areas, and every week or every month, they go down to bigger villages, and there they connect to the Internet. They know what the Internet is. They know all the entertainment that it brings. They know all the business that it brings. They like it. But when they go back to their small villages, they are not connected because we're failing to connect them as an industry. There is demand for connectivity. But what is the problem? That there are many, many challenges. These are complex geographies. This is places in the jungle, high up the mountains. They are remote locations. So it is very expensive for us to deploy the networks there. And it's also places with very limited population. So the population is very dispersed. The density is very low, which means that when we deploy an antenna, we can cover few customers because there are few customers there. So that makes it hard to make it sustainable. Because, of course, we could go to some village somewhere in Peru, connect it, take some pictures, do some PR, and then lose money forever after. We can do that in a few places, but it is not sustainable. If we really want to connect 100 million people, we need to find a business reason to do it. And for that, we need a new technology. We need a new approach. We found also a very interesting opportunity here. These remote locations are fantastic places for experimentation. In downtown London, we cannot experiment much. If the network breaks in downtown London, we are in trouble. Not because the customers are different or better than the customers we have in the jungle. All customers are the same for us. But because the expectations that these customers have. The customers in London expect that the connectivity is always perfect and it always works. The customers in the jungle or high in the mountains don't have connectivity. So if we provide them with good enough connectivity, they are extremely happy, happier than the Londoners, I would say. So that allows us to take more risks. That allows us to try new things. So that's what we did. So what objectives did we have when we started this whole program? First of all, we focused on the RAN, and we focused on lowering the cost of the radio access network. Because in many places, we already have 2G towers. So the civil engineering is not the issue. It's already there. It's changing the electronics up there to provide 4G and then 5G coverage. That is what is really expensive for us at this point, because we're talking about thousands of locations. So we wanted a new cost structure for the radio. But we wanted to provide the same performance as we have in cities. The same performance as we have in cities. And these are extremely challenging locations. Bringing the fiber up there or even the radio link is quite complicated. And operating up there is also quite difficult. I've been in many of these locations talking to customers. I can see that they want the connectivity, and I can see how hard it is for us to do it. And finally, we thought that openness was a key solution, a key component of the solution that we wanted to design. Our solution had to be open in order to enable innovation, to enable anybody in the ecosystem with new ideas to help us achieve the connectivity of all these people. OK, so what are the results after 1 year of work? So it is promising. It is quite promising, the results that we have gotten. In terms of cost, there is one key insight here. A lot of the complexity, and therefore the cost of radio networks, comes from the fact that they are designed for very dense urban environments, where you have a lot of interference, you have buildings, you have a lot of people. It is a very challenging environment, and the networks are designed for performing extremely well there. But when you're going into rural, in all these places that are unconnected, many of these challenges disappear. You can build simpler networks. You can use very few frequencies. There is no interference. There is very few people per cell. And with that, you can reduce the cost. So simpler RAN is the way to reduce the cost. What we've found in many trials that we've done this year is that we can reduce the cost from 5 to 10 times the investment we have to do per inhabitant covered, basically for unit of revenue. And we also found that we can reduce 3 times the investment needed to provide 1 megabit per second compared to cities. So this is what Open RAN in these early trials is bringing to our business. It's pretty encouraging. That's why we're continuing to work. In terms of performance, it's not bad. I mean, it's starting to work pretty well. We've done more than 30 field deployments, small scale, in Peru mostly, but also in Colombia and Argentina. And we've seen that with 6 different vendors that we have been testing in the lab for the last year, the performance in general is pretty good. And as Jago was saying, they are behind a little bit in the 3GPP specs. They are not implementing the latest release. But as I said before, that's not that important in this kind of environment, because a lot of these new releases are trying to solve the urban issue, the urban challenge. And moreover, this two-release gap is being closed by many of these companies, and eventually they will catch up. And also, we are seeing a similar spectral efficiency for single carrier sectors that we're seeing elsewhere. So these results are really encouraging for us. Now, about the openness of the ecosystem, what we're looking here is for cost efficiencies and also for flexibility. The first efficiency that you get is when you split software from hardware. Part of the hardware in the radio network is very specific. You have antennas. That's what it is. But part of it is general purpose. It's just there to compute, to do some signal processing, etc. If we are able to move that general computing into general purpose computers, the costs go down because we reach the volumes of general purpose computers. Your computers, any server, can be used in these radio networks. And those have huge volumes. They are the cloud scale, whereas the telco components only have telco scale. So by introducing cloud scale components and hardware into the solution, we can lower this unit cost. So that's quite interesting, a quite interesting property of open ecosystems. The other one is that today we are in what we call the 2G trap. We have many towers with 2G, but in order to upgrade them to 4G, we need to send people, we need to remove the hardware and put a new white box or black box in there. That's very costly, and that's why in many cases we are not doing it. We hope that by having hardware and software split, in the future when we need to upgrade, we will do just a software upgrade. And eventually we will have to replace the hardware, but it will last many more years. So that's very important for us to keep this flexibility, to innovate at the speed of software, not at the speed of hardware deployments in remote locations. Then openness enables new entrants to participate into the party. So right now, if you have a very innovative technology in a very specific part of the radio network, it's very hard for you to sell to operators because you don't have the end-to-end system. And what we have been buying traditionally is end-to-end systems, including service. When we open the ecosystem, we hope to enable smaller companies that are best in class in a very specific part of the solution to provide it to us and to improve it and to have a new release and go as fast as we are used to in the software business. And finally, we hope that all these learnings can be transferred into our regular city operations. So we test in rural. We provide connectivity to these people that are unconnected. We do it in a sustainable way, so it is a growth factor for us. And in all the process, we improve the technology by means of openness and innovation so that we can use that same technology eventually in cities, in high-dense areas, once it is proven and mature. OK, so far so good. But this new value chain for RAN is not as simple as it was in the past. Traditionally, what we do is that we have a provider of RAN technology, a provider of support, what happens if it breaks, and a provider of service. Who goes there to fix it if you have to move people to fix stuff? This has worked extremely well, and we still use it massively in most of our deployments, this model. And sometimes this is just one single provider. At the beginning of 2017, when we started thinking about Open RAN, we thought, OK, we're going to split hardware and software. So we'll have a provider for software, another one for hardware, then service and support. Now we're evolving our thinking, and we're seeing that there are more actors here. We will need node integrators to put together all the technology. We will need network integrators to connect that to our networks. The challenge here is to enable this ecosystem to work properly, keeping the openness of it so that we have the best-in-class people in each of these layers of the value chain, and, as I said, make it work. This is more complex, but I'm sure there will be new companies or traditional companies that will start providing these very specific services to make an Open RAN work in the field. OK, so in the same fashion as Vodafone, we are going to start scaling these deployments. As Yago said, we already know that the technology works. Now we need to focus very much on the operations and maintenance. We want to make sure that the end-to-end deployment, the end-to-end operation works really well. So initially, we'll do a pilot in Peru, then another one in Colombia, and then another one elsewhere in Latin America. And we'll do it with the RFI winner. We decided to do this RFI together with Vodafone because we also think that we need to change. We also need to do things differently if we really need this kind of growth. So now Yago is going to explain all the reasons why we did this common RFI, and then we will move on to the final results.
Why did we do this? So what were our objectives? Well, I think it's clear by now. Number one is foster innovation. But beyond just accelerating innovation, I hope it's clear that our ambition is to actually have a new cycle started. So if you think on 4G network today, our current 4G network, any operator, if you look at how much and how far we took it, it would not be the same if it wasn't for the innovation cycle that is finishing now. So 10 years from today, I hope I'm still here. I hope I still work. I haven't retired. And I come and say, well, we brought 4G and 5G to everyone in the world because of the cycle that started 10 years ago. It's very ambitious, but it's very important. Other than that, and more operationally, we want to focus our effort onto what we think is the most promising companies to work with. We want to focus on the leaders. We want to focus on the companies that are closer to realizing our vision. And that's exactly what we're going to do throughout the next 12 months. Then, of course, we want to send a signal to the industry. And I hope it's clear that we're serious about this. Not very often you will see Vodafone and Telefónica presenting together, joining efforts, and driving the same in the industry. And you're seeing that today. For that, it's very important that we align the different operator requirements and we drive a single specification that is good for everyone. So
the response to the RFI has been fantastic. It has surpassed all our expectations. We received more than 20 fully compliant, well, not fully compliant, but more than 20 responses. And many of these names are not household names, not even in your homes, right? You're from the industry, and perhaps you don't know some of these companies. It's amazing the amount of innovation that we're seeing. It's amazing how the solutions differ slightly, and the amazing work that all these companies have done. At the top, you have the companies that actually sent a response, and at the bottom, the companies that were indirectly engaged through partnerships and through main contractors. So we were very pleased with this way that the industry stood up to the challenge.
How did we score? How did we evaluate, analyze, and came up with our focus areas? Where there are 3 pillars. We looked at openness, we looked at performance, and we looked at time to market. What did we find? Well, it's very interesting. So in openness, actually, almost everybody, the 20 players, with exception of 5, scored really, really high. You see that we set the threshold on 60% of kind of our requirements. So you see in blue, anyone who's better, 60% or better compliant to what we asked. And then 5 people who's still working on opening their interfaces. In performance, that is really interesting. Everyone was compliant to 4G requirements in that they are delivering a 4G system. But not many people were actually delivering a 2G or a 3G system. We think that's wrong. We think we still need 2G and 3G. But we can't fall on the 2G trap, as David was saying. For that, we need a software-defined radio that's capable to do 2G. Not everyone is going to have a VoLTE-capable device on the environments that we're going to be rolling these things out. We will need to fall it, the voice to fall it back to either 2G or 3G. So when you then look at time to market, actually the 4G readiness is pretty good. And there is a lot of companies that we can pick and mix and choose to go to market very early. And the few that are not ready yet, they'll be ready in the next quarter or 2 quarters. Now, the 2G and the 3G landscape, which is not great now, it has a good improvement path. So we think that in the next 6 months to a year, we will be in a very acceptable place.
Yeah, in fact, this graph shows exactly that message. In green, you see all the companies that were somewhat compliant, up to 86% in the different technologies, 4G, 2G, and 3G. And in red, you see the uplift that some of these vendors are promising for July 2019. So you see very good uplift in 4G, but also particularly in 2G and 3G. That's very promising because we need the overall solution. So, okay, so finally, you have reached the point where we're going to announce the result of the RFI. So, Yago, you can start with.
So we've structured our conclusions in blocks. So at the bottom, you see 2 blocks named innovators and challengers. Well, what is that? So innovators are partners who actually delivered some elements and some clever bits of technology that are beyond our specification. ASOCs have a very clever way to deliver accelerators that may be very important for us to narrow that gap of 2 releases on 3GPP. And Fluido, they have a really clever way of compressing the front hole that we can use on our future specifications. So we'll be working with you guys, and you will have a lot of influence of our next version of a spec. And then in terms of challengers, those are 4 very interesting companies that, even though we think they're not ready to deliver just yet, they have promising plans and very good roadmaps, and we want to keep working with them to ready them in the next year.
In the radio hardware, we see NEC, base cells, and parallel to be the most compliant, the companies that are doing stuff that really is close to what we need. We expect to see here more entrants or even established companies in the future. They are very good radio hardware providers that only have one issue today, is that their solution is not fully disaggregated. The minute they disaggregate it, it will be here, and it will be part of our solutions.
In terms of software developers, our choice and our favorite ones, this is where most of, you have a lot of different choices. There's a lot of developers, and this is really, really good. And in the future, I think we'll have even more. But you see that we picked, parallel wireless in the 3 technologies, 2G, 3G, and 4G, then Fairwaves on 2G, then Mavenir on 3G, and Altiostar and Radisys on 4G.
And finally, the best, most compliant end-to-end platforms are those provided by Parallel Wireless, by Altiostar and Mavenir. And in the next few months, we will be launching bigger proof of concepts, bigger pilots with all these companies to take a look at the end-to-end solution.
Exactly. So Mavenir and Altiostar, see you in Africa. So we said we would also announce the CrowdCell RFI results. And there you go. There they are. So we have 2 runners-up, Arisent and Alpha Networks. Really interesting solutions, really promising. We want to keep working with you. You may not be ready just yet, and like the level of compliancy was slightly below 50%, but it's promising, and I think you'll get there in 6 months. Now, the one company that delivered to 85% of our requirements and we are really impressed with is Lime Microsystems. Really well done, guys. It's impressive set of partners that you are collaborating with to deliver every single variant and kind of possibility on your crowd cell, from like network in a box to other stuff. You can really run this thing on a Raspberry Pi and turn it onto a GPS if you want. You can run a GPS in the morning and a 4G small cell on the afternoon if that is what you want. With that, I think we're done, are we not?
We have the next steps. So what is our call to action? For vendors, if we start at the bottom, focus on meeting the minimum viable product requirements. Don't overcomplicate the solution. Just build something that is very simple, but that help us reduce the cost to connect the unconnected. If you do that, we will grow, and the whole industry will grow with us in these regions. Secondly, address all the roadmap shortfalls that you have learned from this RFI. Those areas where you're still not the best, work on those, because we are very open to any kind of supplier. And finally, leverage partnerships. We've seen here some very good partnerships between best of breed in one particular place in the value chain and others that can complement. I think this is a new cycle for the industry where partnerships are going to be very, very important. For operators, we need to work together to drive industry engagement. We need to work together to agree on a common set of specifications. This RFI that we have launched together with Vodafone is the beginning. It's pretty comprehensive. We can still improve it a little bit, and we are welcoming any other operator that wants to join, because when we send a clear signal to the industry will come back with good news for us. Focus on open and reusable interfaces. That's the only way this whole puzzle is going to work, if the interfaces are very well defined. And don't try to ask for too many variants. Very few variants is what we want here to drive volumes. And finally, we need to focus now as operators on the operating and maintenance. We are not naive. We know that that's the part of the equation that needs to be resolved. Yet, we have been able to bring a lot of innovation in the actual hardware and software. We are convinced that with the trials that we're going to do in 2019, we're going to solve as well all the operational issues that come with this new model and that come with these remote locations. And with that, it's been a pleasure sharing this stage with you, Jago.
Thank you very much. Well done. Thank you.